from the next two examples, are they ambiguous or non-ambiguous cases? So if angle A is 25, side A is 3, and side B is 6.5, draw a diagram. Because there might be an ambiguous case, the two given sides, be able to see if it's ambiguous, I sometimes try to set it up in this style. Like I draw the two sides on the top, and that's going to help enable me to see, is the angle non-included? Is it over here or here? And is it opposite the shortest side? So I try to sort of set it up in this style. That's just my way and that helps me to see if it's ambiguous or not. Okay, so here's the given acute angle is 25 degrees. So I'm going to draw the shorter side on the left and the longer side on the right. So the shorter side on the left, the longer side on the right. So that would mean that's 3, and that's 6.5. Okay, I'll go do some work out right there. So A is 20, and so that side A is 3, so that means angle A is down here. Angle A is down here, and it's 25 degrees. Which means that this one, and that side B, according to the question, which means down here is angle B, and that one's C. Because the angle A is opposite side A, angle B is opposite side B. So I didn't draw it very exaggerated, like 3 and 6.5, but still, it's hard to see that. I should have probably drawn it a bit more exaggerated. I should have maybe made the side 3 a bit shorter, do you think? To make it more easy to see. Because then you would see the pendulum a bit better. Do you want me to draw it again? No? Okay. But yeah, so in hindsight, I would have made the 3 a little bit shorter, because that's a bit longer than half of that, and it should be less than half of that. So we'll do that here.
Wait, what happened?
In hindsight, I'll show you how I would have drawn it. I would have tried to make sure that my 3 was like whatever that is, and that my 6.5 was like a bit more than double, because 6.5 is a bit more than double. And that might help you to see a bit better the fact that there's a pendulum swing there.
Mm-hmm.
So then you would have had 3, 6.5, and 25 degrees. The way I've drawn it's sort of a bit hard to see the pendulum swinging ability. Is this going to be, if it was a sine rule problem, is it ambiguous, this one?
Yeah.
Yeah, why?
Because you don't have the inclusive angle.
Yep, that's true. The two conditions are applied. So we have the not given the included angle.
And also the angle that we were given is the opposite of the shortest side.
Yeah, exactly. Yep. The acute angle given is opposite the shortest side, so it's ambiguous. The acute angle given is opposite the shortest of the two given sides. The shortest of the two given sides. So we have ambiguity. So ambiguous. So it just means that when it comes to maybe using a sine rule, we'd have to use the find one angle, and then we'd have to find the alternative version of the angle. So just showing you that if that side 3 is here, you can swing it so that instead it goes down this way instead.
But Miss Elisa, how did you know that? Is it because they put that notation of the A, that's how we knew that it was between A and B, side A and...
Oh yeah, angle A is always opposite side A. That's just the rules with these triangles. Angle B, sorry. Yeah, that's a good question though, yeah. Angle B is always opposite side B, and angle C is always opposite side C. That's good to remember that stuff. Because that's important. Millimeters, yep. So it turns out this one is going to be an ambiguous case, so you just have to be aware of it. Which angle is the one that's going to have two different answers? Angle C or angle B will have two different answers.
C?
Why do you say C?
I guess it's B then.
Oh, you haven't. Yeah, why do you say B, Paige? Yeah, so B, it could like, because this length here is the one that's swinging. This is a pendulum that's swinging. So that which affects angle B doesn't, well, it sort of affects angle C really, doesn't it? What am I saying? So it can affect angle C too, of course. So B and C, yeah, it affects both. Yeah, you're totally right. Yeah, because see, angle B could be either this one or the acute version or the obtuse version. Similarly, angle C would then be the obtuse version or the acute little version here. So you're right, both of them are going to have two different answers as a result. So find angle B. So what we've got is sine rule or cosine rule. You've got two sides and you're dealing with
Opposite angles.
two opposite angles. So which one do you use, sine rule or cosine rule? Sine rule, yep. And it's going to be an ambiguous case. So find angle B, you just have to realize there's actually two answers. It might help you just quickly draw it out again, just to prove why you use the sine rule. Feel free to do that. Because we've got theta is the B, and this one is 25. Here we've got the 6.5 and the 3. So two sides and their opposite angles means sine rule. In this case, it's the ambiguous case. Because of that. So there's going to be two answers. So you just do, to find the two answers, you just find the acute answer, just doing the sine rule the regular way. To find the obtuse answer, you just do 180 minus the answer you found from the sine rule. So again, I tend to put the thing I'm looking for on the top. That's just my favorite way of setting it up. Like I might go, I'll put the angle on the top, sine theta, over, I'm going to put a mistake. So feel free not to write this, I'm going to put in a mistake intentionally. Can you see my mistake?
Yeah, I'm just
I'll be good. Good, yeah, so sometimes that can happen, yeah. So you're right, like the angle has to be opposite and its side. So sine theta should be opposite on and over 6.5, and sine 25 should be over 3. Check if we're good with that stuff. So I'm sure you didn't break that. Sine theta and 6.5. And then you probably rearranged it and found the answer. I've got sometimes do this. What would be our unrounded answer for our angle? 66? And then 66, yeah? 66, very good. And after all that work, it's really easy to think, hey, I'm done. But don't forget, what have I forgotten to do if I've done that? Yeah, find your second answer. So that is one answer, so give it a nice little circle.
Wait, why is it two answers again? And then there's like B2.
Yeah, you can call it, some people call it B.
B2 is like,
And
then the next question
some people call it B and B dash.
C.
Yeah, and there'll be two answers for angle C as well. I just tend to subtract from 180.
I don't like this.
You don't like it?
Is this like a big component of...
It's probably the worst. It's probably the worst thing you'll get. Like ambiguous case isn't in math studies, but it can appear in SL.
Does it appear often?
But
Yeah,
yes,
not a great deal.
I
But
thought
if
yesterday
you
you said no. Oh yeah, because you said no. I just want to teach you it.
oh no, I think you dreamed that.
Wait, so
You might have
also-
dreamt it.
I drugged it?
Dreamt it. Dreamt it.
Okay, that's funny. But
So Grace, sometimes people call the first answer B, and the second answer that we're about to find, B dash. Sometimes people call it.
I'm confused.
You can call it whatever you like.
I'm confused. Explain really quickly again.
B1 and B2.
Why it's two?
Why there's two answers? Yeah,
What?
I'll just show you again. We still need to find the second answer. Remember, it's just 180 minus. So C,
How do we find the two answers for C?
you just do 180.
Subtracts 25, subtracts B1.
Yeah, equals that. And the other one will be 180 minus that one minus B2. Yeah, we'll give you that one. So see how there's two versions of angle B. The one that we've just found is the version if the triangle was drawn like this.
Yeah.
And the other version would be the one if the triangle was drawn with the yellow, like that bit's not there.
Okay.
It's actually this triangle.
Oh, so we're not.
So how?
So there,
why
angle B would be there.
180?
Because, see that's 66.
Yeah.
So this one must also be 66 because the pendulum forms a isosceles triangle.
Okay.
Which means because that's
Yeah. I know
they
what
add
you're
to 180 because they form a straight line. Yeah, good to double check that stuff just to see the reasoning behind it. So let's find our second angle, which we can call B2 if you want, and 180 minus. Let's use it unrounded to be super. What we've got equals, and then if you want, you can write it to 360. What's 180 minus 66.3 blah blah?
113.695.
698530. So 368.
114.
Yeah, 14. Confusing, isn't it? They might say, though, sometimes in the questions just be where they might ask for one decimal place for angles. So there's our two answers for angle B. So you could call it B1, B2. Some books call them B and B dash. However you want to set it up. So find angle C. We can just use the fact that angles in a triangle add to 180. So maybe let's make a note of that because we might look at our working out later and go, hey, how do we find that? Angles in a triangle. At the moment it makes sense, but looking back it might be a bit of a jumble. Add to 180 degrees is our reasoning. So you could call it C1 and C2, or you can call it C and C dash. You can just write the numbers if you want. So 180 minus the 25 degrees minus the 66.301 gives us roughly.
This will give us C again.
Was it? Something 7?
88.
88.7? Okay, let's just have it around if you want to get sure.
Yeah, I heard
Yeah. And then if it was an assignment or a test or something, you might do that rounded. Just a bit. And then the alternate version would be 180. It's still minus 25. The 25 degree angle doesn't change. That's fixed because that was given in the question. Yep, sure. And then minus the other version, minus the 113.69. Oh, you can tell me just the unrounded answer if you want. I mean the 360 answer. Did you get something like 90 something? Oh, sorry. Ignore me then. No, what was it, sorry?
41.
41, right. Sorry. Oh yeah, I don't know, I can't add. 41 point something? 41.3 degrees. No, you guys are right, don't worry about that. I'm thinking of angle B. I was doing 180 minus the other one, but that doesn't apply to C. It was B that forms the ambiguous one that we work out using 180 minus. So that's pretty interesting. And now find the length of side C. We can use all sorts of things. To find the length of side C, we've got so much info. Sorry, some people are writing this down, so I'll wait before I scroll up. Side C, does that have one or two answers?
Side C.
1.
You could go. Oh.
No, I thought 2.
Two, yeah. And so it's a bit of a pain, isn't it? Have I given you much space to write this answer? How much have I given you? A little bit. So what you might want to do is draw out two triangles. Draw out your two triangles, and then pop in the angles that you've got so far. Because one triangle, side C is the bottom one. See if you use this version, it's a long length. If you use this little version, it's a short length. So you might want to write out both triangles for now and kind of work them both out separately. This might be similar to one you were asking about, Katie. Yeah, sure, let's go back up. Do you mean up to the top?
Yeah.
Yeah.
Because I'm pretty sure we don't have the same thing.
Oh, yeah. Yeah. Did you see me? Yeah, sorry, that was, yeah, I put a boo-boo. I said, because I said find the length of A and B, but that's in the question. Sorry about that, because that would have been easy. You'd already know length A and B. What's that, you want back here? Oh, you're just quickly drawing the triangles, are you? Yep. Yeah, so down at the beginning of question D, I would just quickly draw out that triangle with the angles, and this one, just this one here, with the angles in there. And then pop in the angles and things that you know. Yeah, sure. Are you done with this one, babe? No? You're just having enough? Having a moment? So here's the version with your cubes, and here's the version where we kind of swing it. Yeah. Oh, that was rich again. Is this one angle A down here?
Yeah.
That one is 25. So that one's locked in at 25 because it's part of the question. This length was 3 and this was 6.5.
Yeah.
3, 6.5. And then you could, so we've got 3 and 25. If you want to use sine rule, you can. You could also use cosine rule if you want, because you know that angle. So you could use cosine rule because you know this angle. So you could use cosine rule for a length using x, that and that. Or you could use sine rule because you know. You can use sine rule because you know this angle too. So feel free to practice using whichever one makes you happy. Sine rule, cosine rule, because we know. Yeah. This one's angle B. Yeah, because you know angle C, because you worked out angle C up here. So you could call this one X. If you call, like, of course, this is what we're finding, so call them both X. Call it X1, X2 if you like as well. That's a good idea, like just to have yourself set up nicely like that. That is actually a good suggestion from Grace. Call one of them X1, call one of them X2 if you like. Some people, yeah, do that. So then if you need to go back and use that answer, you know what's going on. Because you know this angle here, and remember 3 sides and an angle. So long as you've got the angle opposite the unknown, you can use cosine. Yeah. So you can practice both. You might sometimes you might get a slightly different answer. Like you might get something that's slightly out by a few decimal places, depending on if you use sine and cosine. So the mark scheme allows for both, which is pretty crazy. Yeah, so I need to put in the angles. That's what I've been avoiding doing. Putting in angle B, 66.3 or 66.30 blah blah. Dot. Or you could use the obtuse version, which was 113.69 dot dot dot. Using animated version. That's 66.301 dot dot, 113.69 dot dot dot. Yeah, you can, so feel free, you use cosine rule or sine rule if you want. We might find we get a slightly different answer. I think I'm just going to use sine rule. Oh, yeah, of course we don't use B. Yeah, no, I shouldn't have even, no need to bring me in even put in B, because for both cases we need C, don't we? Yeah, so we need C. Because, so in a way you don't have to have written in the B. What am I doing? Not wrong if you did, but I don't have much space to write my C, so I'm going to undo that. Just so it's a bit neater. No problem if you did put in that. So it's a C that I need, so I should be putting that in instead. That's the problem with C. The problem is the fact that I didn't write my unrounded, and I'll need my unrounded to do this question. So you can sort of see the hassles if you don't discipline yourself and make yourself right in the unrounded. It causes you a problem later on. Okay, let's say, was this something like 88.69 or something like that?
88.69853073.
And what was the other one kind of unrounded? What was it? 45?
41.3046.
Okay, that's good. Thank you.
Wait, can you say the unrounded for both again, Sarah?
For the 88 one, so you want is 88.69853073.
Uh-huh.
And then for the 41, it's 41.307469.
Thank you.
So Paige, I just noticed where you're going. I started filling in angle B, which is fine, but to do the sine rule, I need angle C. So because I didn't have much space for my triangle, I erased off my B. Because I didn't have much space to write in both angles, that's all. So because to find x, we need in the sine rule, or the cosine rule, is angle C that I need. So let's try doing both. Let's do x over sine 88.69 equals 3 over sine 25. So 3 and I've chosen to use the 3 and the 25 because that's the side we know. And also angle 25 is a nice whole number. I could have used 6.5 in angle B, but then I'm having to put in another ... number, whereas 25 was easy to put in. So then you'll get
You
hopefully...
can use the cosine rule for this question as well.
Yeah, totally, yeah, exactly, because you've got 3 sides and you've got the side opposite, the unknown side. Yeah, and sometimes you get a slightly different answer just by a couple of decimal places. But that's okay, that Mark Skin has both answers. 3 sine 88.69 over sine 25 equals unrounded answer. Anyone got an awesome unrounded answer, or should I? I don't know if I calculated.
I did the cosine rule for about 7.096.
Yeah, that's right.
So the 366. Yeah. And did I give you any units or anything for them? So this can be a bit of a nightmare question because then now you've got to work it out for this one. But same working out that you use cosine rule or you can use sine rule. Cosine rule is probably a bit less than working out, isn't it? Because in a way, like you're just putting it all under a square root and then it's all just being worked out in one big nice step.
Wait, were you supposed to, you got that with sine rule, right?
Yeah.
And maybe just for the sake of showing you.
Oh, because I never used the bracket y equals thing. I mean, not bracket.
Oh, the fraction, alpha y equals, yeah. Yeah, it makes a big difference sometimes. So let's do the cosine rule.
Whoa!
Showing an example
What am I
of
doing?
cosine x equals 6 square root 3 squared plus 6 squared minus, I just wrote 6.25 squared, 6.5 squared minus 2 times 3, 6.5 because 21.3 make sure you square root this all the way. So see, like, the cosine rule is nice. Just make sure you pop in the unrounded answer. So long as you write in a few decimal places. And then we can
4.68522773. 4.62.
Very accurate, very good number reading. Okay. Do you guys agree? If you use the sine rule, it's not wrong if, like, sometimes it's slightly different. Slightly different answer. If anyone got a really vastly different answer, let us know though. Because it is possible that they can come out slightly different if you use the sine rule, just a small difference between them. Nice. When it's not, so when it's ambiguous, it's double the work almost. When it's non-ambiguous, it's not as much work. It's just a nice regular question. Some people are writing that down. So being able to set up the triangle to decide if it's ambiguous or not is a skill to develop. What's really nice is when they give you a hint. It does happen a lot in exams, like they'll give you a hint and they'll say, what are the two answers for angle something? Or, except for that question. Yes, yeah. Anyone still writing? Yeah, it's okay if you are. Yes. Yeah, that's good. Okay, yeah. Yeah, it's only that sometimes it's slightly different with the sine rule. That fella. Do you see the I put an ambiguous cartoon in?
I don't get it. They would always yell, "Lassie, get help." Who? Start again. So you know how there's like an old there was like a colony, and the dog was super smart, and the people would always get stuck in like wells. So they'd yell, "Lassie, get help," and she'd run and go get help. Yeah. And then in that. Oh yeah, that's right. Okay. Are there Lassie?
Hope nothing inappropriate comes up. Come on.
My hand hurts. I never get it. Oh, that's
What is this? That's Lassie. Yeah, like Lassie was the super dog that kind of saved everyone. And you know how they speak to the dog, and the dog, it's like the dog understands them. I think is this old? No. It's like this looks like early 80s Lassie.
What is this supposed to be said?
I think early 80s. Have a look. The soft focus, the hair. Okay, enough of that. So that's why, hence the ambiguity of that.
How do people get stuck in wells? They fall. But why would you need that close then?
That's a good reason.
I've seen the movie Grace. She died at the well. That's why she calls people.
Wait, is that
Oh, that's a Japanese film?
Yeah, she comes out of the thing like.
where does she come out of?
She comes out of the well. She climbs out of the well.
I don't listen to
I'm so trying. Can you say ring or ring? Is it?
Ring.
The Japanese film. Oh no, there's an American version of the Japanese film. Yeah, I think it came from Japan and they made an American version. Isn't it?
She's like, she wants them on her. No, she loves people because she wants revenge.
Yeah, so she's
Somebody
pushed her in. Why did
So I pushed her in the well and then they left her there. And then
and she died.
Yeah,
So how did she get the ring? So where's her body?
This all came from here.
Yeah.
The ambiguity of
Oh,
that. Have you heard of the TV show Lassie?
So why don't they just take her body
Because
out?
you were saying Lassie, go save someone's fallen in the well, go get help.
it's already like still.
I don't really get
Lauren
it.
was trying to describe what the TV show Lassie was like.
I get
That's where
it, but
something's falling down the well.
I just don't understand how they're gonna match.
This one.
How does this relate to math then?
It doesn't. It's just from Lassie. Because remember, like, Lauren's example was Lassie, go get help, someone's fallen down the well.
Yeah.
And then someone asked, how can someone fall down the well?
So that's why it's ambiguous.
Okay, so here's another one. Let's decide if it's ambiguous or not. Angle B is 52, side A is 5, and side B is 9. So I'm going to set it up, little side here, long side over there. I sort of set it up like that. Okay, let's put little side here, 5, that's side A, so that means that's angle A. Side B is 9, so that's angle B, and that's C. Let's put in that angle they gave us. They said angle B is 52.
I don't understand it.
Yeah, we've got to decide if it's ambiguous or not. Does it follow that criteria? First of all, did we give you the non-included angle? Is the angle we give you the non-included angle?
It's not ambiguous because we can't move the long side because it wouldn't be the same length if we moved it to the left, so we can't do it.
Yeah, if you swung side, yeah, if you swung side CA, it's not going to be a triangle
We can
anymore.
only swing the shortest side.
Yeah, this side is locked as being 5, kind of. You can't suddenly make it longer or anything.
I'm confused.
Yeah. So when you swing 5, because it's the shortest angle, it can go like that to make like an isosceles, right? So this angle is the same as the 5, right?
I can't. Are you saying it from my way or your way?
It doesn't matter. This is 5 on the board,
Yeah.
and then this, if you swung it, so it's here, and then you swung it, it's supposed to be isosceles, so equal, so both sides are 5. But if the 9 is like really long, and if you swing it in, it doesn't, you can't do
It's
that.
not going to be 9 anymore.
Yeah.
It's going to be like 7.
Yeah, it's going to make it shorter because the line on the bottom's there.
See that if it's ambiguous, this shorter side is free to swing.
So why
Side
can't that
5
side
is
swing
free.
anymore?
Because the 52's locked it in.
Oh.
Whereas if the 52 was over on the angle A, then it's so not ambiguous. As the acute angle given is not. Actually, to be honest, I made a mistake. I was meant to give you angle C, but I forgot. Okay, is not. The acute angle given is not opposite the shortest given side. I think that's right. I'll get back to you if I did. I was actually, in hindsight, I was meant to have given you C. I wanted to give you one that's really obviously not. Like, it was meant to be, I gave you the included angle. But it's. Let's go with this. Oh, that's right, I was meant to change that one to angle side C. Oh well, we'll just do this one. Okay, alright, let's try this one. Okay, so we drew a diagram. Let's just go ahead with this. Find angle A. So which one do you want to use? Find angle A, that leader.
No.
Yeah, good. Why did you choose sine, Sarah?
Because we have a length, 2 lengths, and an angle.
Yeah, sides opposite, yep. Cosine would need another length. Similar set of questions. Find sine A, practicing it again. And sine theta. Find. Anyone have that unknown answer? And 360. Yeah, 26.0. I think I might have, did I think these are my free 26.0 degrees. It's an angle. Good. So Sarah's made sure to keep 3 sig figs by putting the point 0 at the end. Otherwise she would have rounded to 2 sig figs. Find angle C is nice and easy because we know angle, yeah, 180 minus, yeah. Minus 52, minus 25, minus 62, minus 60. Yeah, look up. Cool. And 3 sig figs, is that 102.0? Yeah, 102, good. 102. And then we're asked to, last one, find the length of side C. more space for that. Find the length of side C. We'll need to use which angle to find the length of side C? Angle C, yeah. So regardless of whether you use sine rule or cosine rule, it's angle C that we need to have on our triangle. Is definitely required. Use sine rule, cosine rule, whatever you make you happy. That was a regular one. It's good to see an example of one where it's not ambiguous. Supposedly. If I got that wrong for some reason, I'll get back to you. I was meant to give you the included angle to make it really clear it's not ambiguous. That's that. It's 209, it's 210. Do you want to sort of stop there?
Yeah.
Yep, area of a non-right angle triangle.